Lesson 14, solving systems of linear equations without graphing. Go ahead, we're going to have you do number 1 on your own, which is we have this graph of the system of equations y equals 3 and y equals 7x minus 8. You're going to estimate the coordinates and then determine whether your estimate was correct. So here's just a quick sample of what I tried. I thought it was, between 1 and 2, so I did a 1.53. And then I plugged that into my equation. Y equals 3 works for the first equation. But for the second equation, y equals 7x minus 8, when I plug 1.5 into that, I get 3 equals 2.5, which isn't a true equation. So my ordered pair didn't work. I assume yours didn't at all. Because the problem here, and I'll zoom in even more, is that we know it's on the y equals 3 line. That makes your y coordinate really easy to figure out. But all we know is that the x coordinate is somewhere between 1 and 2. But without any further grid lines, we can't assume where specifically it is on that line. So now we're going to talk about how we can do a calculation to solve this without graphing. Number 2, I already have complete. I'm going to zoom out a little so you can see. We'll do the last part is just checking how to solve it. So we have the equation on the left, y equals negative 3x plus 2 and y equals 8. Graph it and then find the solution. And we can identify the solution perfectly because negative 2, 8 is on the grid, so we can see that point. And then, of course, checking your work, x equals negative 2. That works. Y equals 8, of course, works because we used 8. And then plugging negative 2 and 8 in, we get 8 equals 8. So that's great. Problem B, though, gives you the equation 8 equals negative 3x plus 2. And you solve it mathematically, you get x equals negative 2. When you plug negative 2 back into here, you get 8 equals 8. So pause if you need to so you can copy down all my work. Let's scroll down to here. For problem B, the equation is made by combining the two equations from the system of equations in problem A. Since we know that y equals 8, we can replace y in the other equation to make one equation with only one variable. So we had two equations before, y equals negative 3x plus 2 and y equals 8. Because we know y equals 8, we can put that in for y and get the equation 8 equals negative 3x plus 2. So again, pause if you need to get all your notes, and then we're going to go on to number 3. So number 3 here at the beginning, we have y equals 7x minus 8 and y equals 3. And for all of these problems we're going to be doing today, if it helps, draw yourself a tape diagram. So 7x, we have 7x's plus a negative 8 or minus 8 is going to equal y. And then we also know y equals 3. So we know these two things are the same, which means we can then replace y in that top equation with 3 and get 3 equals 7x minus 8. On your own, solve and then check the solution by plugging your y and your x into this top equation. And what did you get for your solution? Here's where you can check your work. You can see what I've done here. I rewrote 3 equals 7x minus 8, solved for that, and I got x equals 11/7. And then plugging y equals 3 and x equals 11/7 into this equation, I get 3 equals 3. You might not have had 11/7. You might have had 1 and 4/7, or 1 in some sort of disgusting, ugly repeating decimal, which is fine too for today. So number 4, I'm going through the step-by-step how you can solve using what we call the substitution method. So here we have y equals x plus 10 and y equals 3x. So we have these two equations. Here's my tape diagram, x and 10 and 3x, and we know both are y. So we can rewrite the system of equations by setting everything that equals y to each other. And so that's going to be this equation here. Because we know that y equals y, they're the same thing, we can plug x plus 10 in for y on one side and 3x in for y on the other side. So that's step 1. Step 2 is to then solve the equation for x. Do that minus x on both sides, we get x equals 5. That's great. Substitute, we then substitute 5 in for x in one of these equations. You pick one and you plug in if x equals 5. So I've picked this bottom one, y equals 3x. Replace the x with 5, y equals 15. And then we're going to substitute by using it back both y and x into the other equation, the one we didn't use, y equals x plus 10, to check your solution. So if we plug in 15 for y and 5 for x, 15 equals 5 plus 10, 15 equals 15. So that is our solution. So we can say then the solution to this system of equations is 5, 15. Go ahead, you're going to do number 5 on your own. If it helps, I've done a little bit of work. I've drawn you a tape diagram. I've also highlighted where we have our y's. Just because it's written in a different order doesn't mean anything is different. Following these 4 steps, solve for your ordered pair that is the solution to the system. So number 6 looks a little more complicated. We don't have just a y equals or an x equals. But what we do know is if x equals x, then we know that 3x equals 3x. That's our multiplication property of equality. If we multiply something by both sides, it still stays true. So if we know 3x equals 3x, we can replace 3x with 3y minus 6 and 3x with 2y, and then solve. Let me know when you solve for this what you get for y. What you should have gotten is y equals 6, and then picking one of your equations to plug that back into, you're going to end up with x equals 4. So I used 3x equals 2y, plugging that in, you get x equals 4. So if we test out the ordered pair 4, 6 into our other equation, which is 3x equals 2y minus 6, you end up with 12 equals 12, which means that our solution is 4, 6. You are going to do 7 through 9 on your own. Here's 7 already highlighted for you to help you out a little if you need it. Just like if x equals x, then 3x equals 3x. If y equals y, then y plus 2 equals y plus 2. Just a quick reminder in case you need it, systems of equations can have no solution, one solution in which you should give your ordered pair, or infinite solutions. And again, you're going to be completing numbers 7 through 9 on your own, and then get your notes checked.